In this lesson, we're going to basically put together what we learned in the last two videos about writing augmented matrices or performing row operations to do something called Gaussian elimination. And Gaussian elimination is one of two methods that we're going to focus on in these two videos on how to solve a system of equations using an augmented matrix. So first we need to know what row echelon form or reduced row echelon form are. So in this video, we're going to talk about row echelon form, and in the next, we'll talk about reduced row echelon form. Row echelon form has the following properties. For any rows consisting of all zeros, they're at the bottom of the matrix. So notice here, 0, 0, 0, 0, bottom of the matrix. For all of the other rows, the first non-zero entry is 1. So notice here, first entry is 1, first entry is 1, first entry is 1, etc. on the left. The leading 1 in each non-zero is to the right of the leading 1 in the row immediately above. So here, notice this 1 is immediately to the right of this one. This one is to the right of this one, just by one column. Once we have this written in the correct row echelon form, which either of these are row echelon form, then we can solve the system using back substitution, and that's called Gaussian elimination. So this is one of two ways that we'll talk about. Gaussian elimination is the first. So here's an example for us to do together using Gaussian elimination. Now we know that in order to use Gaussian elimination, we need to have our system of equations written as an augmented matrix. Before I can do that, I have to write my equations in standard form and then write them in the augmented matrix. My first equation already in standard form, but my second equation is not. So I'm going to use the distributive property and then rearrange my terms to put x and y on the same side, which would give me 3x minus 5y equals 1. So my new augmented matrix is 2, 3, 7, 3, negative 5, 1. Now keep in mind that my job is to write this in row echelon form. And remember, row echelon form means that my first term here will be a 1 and below it will be zeros. This term we would want to be a 1 also. So I'm going to do some row operations to make that happen. So the first thing I might do is to take half of row 1 and make that my new row 1. So why would I do that? Because that would turn this into a 1. So that gives me half of 2, which is 1, half of 3, which we'll just write as 3 halves, half of 7, which we'll write as 7 halves. Notice I didn't do anything on that step to row 3, or to row 2. So I did half of row 1 and replaced it into row 1. Now what I want is I want to have a 0 here. I want to have a 0 here. We'll worry about this one in a little bit, but I really want this to be a 0. Because I have a 1 here, if I took negative 3 times row 1, that would give me a negative 3 on top. I'm going to add that to row 2, and I'm going to make that my new row 2. So again, row 1 will remain the same. My row 2 is now negative 3 times row 1. So negative 3 times 1 is negative 3, plus 3 is 0. That's what I wanted. Negative 3 times 3 halves is negative 9 halves, plus negative 5, which would be negative 10 halves, so negative 19 halves. And then negative 3 times 7 halves would be negative 21 halves, plus 2 halves, so negative 19 halves. And what I see happening here is that this is negative 19 halves and this is negative 19 halves. So I'm going to make, if I take negative 2/19 times row 2 and put it back in row 2, these will be much easier to deal with. So my row 1 is 1, 3 halves, 7 halves. My row 2, this times negative 2/19 is still 0. This times negative 2/19, the negatives cancel, the 19s cancel, and the 2's cancel, and I just get a 1. And same thing happens here. So now what we have is we have row echelon form. We made it. And I know that because I have a 1 here, I have a 0 below it, and my first term in my next row, which is just to the right, is also a 1. Now, what does all of this mean? It means now I can use back substitution to find the values of my variables. This equation is now x plus 3/2 y equals 7/2. And this equation is y equals 1. Y equals 1. So I know that in my solution, I need an x and a y. And I have already found that my y is 1. Back substitution means I'm going to take my y value, plug it back into this equation to finish solving. So I'm going to have x plus 3/2 times y, which is 1, equals 7/2. So this is x plus 3/2 equals 7/2. If I subtract 3/2 from each side, I get x equals 4/2, which of course is 2. So my solution is 2, 1. That is my ordered pair that represents the solution to this system of equations. Let's try this one together. This is a three variable system. We will start, of course, by writing this in augmented matrix form. And I really want that very first term, that leading number, to be a 1. And so I'm going to do a little bit of rearranging. I'm actually going to turn this into my bottom row. So I'm not going to write what that is, but basically I'm going to take this one and I'm going to put it on the bottom and shift the other 2 up. Now I have my leading number of 1, and I need the 2 values below it to be 0. So to make this value 0, I'm going to take negative r1 plus r2 and make that my new r2. And to make this value 0, I'm going to take negative 2r1 plus r3 to make it my new r3. Notice row 1 will remain the same. So now my very first row starts with a 1 and has zeros below it. I know that I also need this value to be a 1, and I need this value to be a 0. So before I turn this value into a 1, I'm going to go ahead and use this row. I'm going to use 5 times row 2 to make that a positive 10 so that it will cancel out with a negative 10 to make it a 0. So 5 times row 2 plus row 3 will be my new row 3. Notice that row 1 will remain the same and row 2 will remain the same. So now I have the zeros where I want them, but I need this leading value to be a 1 and this leading value to also be a 1. So my next operation, I'm going to take half of row 2 and make that my new row 2, and I'm going to take half of row 3 and make that my new row 3, because dividing by 2 will make both of those 1. Now I've written this in row echelon form, and so writing it in row echelon form, I know now that I can use back substitution, because this is z equals negative 4. This one is y plus half of z equals negative 3/2, and this equation is x plus 2y plus z equals 0. So I'm going to use the fact that z is negative 4, and I'm going to back substitute to find y. So y plus 1/2 of z equals negative 3/2. 1/2 times negative 4 is negative 2. Adding 2 to each side, I find that y is 1/2. To find x, I'll use negative 4 and 2 back in the first equation. So x plus 2 times 1/2 plus negative 4 or minus 4 equals 0. 2 times 1/2 is 1. 1 minus 4 is negative 3. Adding 3 to each side tells me that x is 3. So my solution is 3, 1/2, negative 4 using back substitution. Here's one for you to try on your own, so try this question, then press play to check your work. The very first thing that you want to do, of course, is to write this as an augmented matrix. Notice all of my equations are in standard form already. So 2, 7, 1, 14, 1, 3, negative 1, 2, and 1, 7, 12, 45. Now remember that the very first thing I want is to have this very first value be a 1. So I'm simply going to swap R1 for R2 on my first step. Now, as I'm working through this question, remember that if you already did this question, you might go about it in a different way, but at the end, you should end up with the same solution. Now that I have a leading 1, I need the two values below them to be 0. So I'm going to take negative 2 times R1 plus R2 to make that my new R2, because that would give me a 0. And on the same step, I'm also going to take negative 1 R1 plus R3 to be my new R3. That will give me zeros below the 1. Next, I need this value right here to be a 0 as well, because remember, this is a 1. I need the zeros beneath it. So I'm going to take negative 4 times R2 plus R3 to be my new R3, because that would give me a negative 4 plus 4, which would give me a 0. Now notice, this is now in row echelon form. I have leading ones with zeros underneath, which means my system of equations is x plus 3y minus z equals 2, y plus 3z equals 10, and z equals 3. So in my system, I know that z is 3. To find x and y, I back substitute. So I take the 3, I plug it into the equation before. So y plus 3 times z equals 10. That's y plus 9 equals 10. Subtracting 9 gives me that y is 1. Then I back substitute with the 3 and the 1. So x plus 3 times y minus z equals 2. So x plus 3 minus 3 equals 2. So x equals 2. So 2, 1, 3 is my solution. Remember that whenever you find a solution, you can plug it back into any of the original equations to make sure that you did the math right.